Okay, so we're starting to make our way back from the tidiness of the mathematical world into the scruffiness of the engineering world. So these are a couple of simultaneous equations which will come up when you do your tutorial. And so what we're getting, because it's engineering, we're starting to get back to some decimal numbers. So we don't have the nice round numbers that you tend to find in mathematical problems. But what I'll do is just work through this example and show that the methodology is just the same, just gets a bit untidier because the numbers get a bit more untidy. So let's have a go at that. So what I'll do is I'll write out these equations and I'll sort out the order. Actually, we're okay. We've got F2, F3 are in the correct order, top and bottom. Looks like we've got a 0 here. Actually, we haven't because we've got a number on this side. Remember, I was saying just bring your numbers over to the other side. So I'll write those out, sort out the order, and I'll just see you in a minute. So I've tidied those up a little bit. So I've brought both of these constants, so they've got no unknown in them. It's just a number, 5.196. I want this to be on the right-hand side. So I've brought that across in this equation. And then I ended up with a whole heap of negatives. So didn't have to, but I wanted to tidy that up just so I'm getting more positive numbers. So I've just multiplied both sides by -1 and ended up with this equation 3. Done the same thing with the second equation. So that's a constant. There's no letters there, so it's just a constant. So I want that on the right-hand side. So I've done that, brought that across. It was +3 on this side, so you have to subtract 3 from both sides. So it becomes -3 on the other side. And then I already had them in the correct order. I've multiplied that one by -1 as well, just to minimize the number of negatives I've got, but probably really didn't have to do that. Getting a bit carried away with multiplying by -1, but anyway, done now. So we're then going to work through the same process. So if one of these ended up with 0, so you had no number there, then you would choose that one to work with next. In this example, neither of the equations have 0 on this side, and so we could pick either of them. So far, we've always been taking the first one. This time, let's take the second one just to show that it makes no difference. And what we're going to try and do is we've got two unknowns. Previously, we'd have x and y. In this example, we've got F2 and F3. So these are forces probably. I'm not going to worry about units in this. I'm just concerned about the simultaneous equations. But probably we're working with F2 forces here. So what I want to do is get one of those in terms of the other. So I want to try and trap one of them on one side and get all the numbers onto the other side. So let's do that. We'll see you on the other side of the fast forward again. So I've got to the point where we've got F2 in terms of F3. So we've got F2 on its own on one side, and then we've got it in terms of F3 on the other side. Because we've got a constant, we can't simplify that any further. So that's us done. And so we figured that out from 4. Okay, so we use the second equation this time just to show it doesn't matter which one you use for this first stage. What we're going to do now is substitute that back into 3. So we're using the other equation. That way we'll get rid of this F2 and we'll have one equation with one variable. Therefore, we can solve that. So let's do that now. So we figured out F3. Now we want to put that back into F2. So we're going to stick this back in here. And then we'll figure out what the value of F2 is. And then all we've got left to do is the check. So for the check, question 4, that came from 2. And so we're going to be substituting it into that. So we're going to stick it back into equation 1 to do a check on that. If ever you're unsure of which one to put it back into for the check, just do both of them. Check both of them are true. If you've got the right values of F2 and F3, both of these equations, 1 and 2, must be true. That's the whole idea of this. Okay, so I'll fast forward through that again. I'll get you once we've finished everything. So we didn't get the right answer here. It kind of shows that it's probably best to just check both equations. I actually did the wrong one first, so we'd substituted 6 and 5. 5 comes from 4. And so we probably didn't want to use this one as a check first, but nonetheless, probably better to use both equations to check it. I should have used 3, but I also checked 3, and I didn't quite get the right answer, and it looks too big to be a rounding error. So I went back again and discovered that I'd transposed, sorry, just clicking the wrong thing there. F3 should have been 5.458. I've written down 5.485. So I need to go back and fix all that, and then hopefully we'll get the right answer at the end. So worked through that, corrected this value, we transposed the two numbers and ran it back through and did the both checks again just to be safe, and we've got their answer. So just a quick summary. Just get it to the right place. So when we're running these types of equations, or we're doing these types of simultaneous equations, first thing to do is probably to check that you've got two equations and two unknowns. If you've got more than two unknowns, you need more than two equations. So you need the same number of equations as the number of unknowns. In this case, we've got two equations, two unknowns, so we should be able to solve it. Then you tidy it up. So you make sure your unknowns in both equations are in the same order, and you bring what's just your numbers, your constants, across to the other side. Maybe you times by -1 both sides to get rid of some negative values. Then you choose one of these. If one of them you've got 0 on this side after you've tidied it up, that's the one you'd use first. And you write F2, well, we write one of the variables in terms of the other. And then you substitute that into the other equation. Okay, so we used 4 first, so we substitute that back into 3. The whole reason for doing that is to try and get a one equation with one variable in it. So we've got this F2, but we write that in terms of F3 so that we've got an equation that just has F3 in it. Then we can use normal algebra just to figure out what F3 is. Then we substitute that back into the equation 5, and that way we get the other value. And then we check it by substituting it back into the original equations to make sure that the left-hand side is equal to the right-hand side. Might be safer to do both of them, but basically if you've used one equation here, you use the other. Check they're both right. If they're not right, go back and fix it. And then once you've got both of those original equations correct, then you know you've got the right values and you've got your answer. Okay, so let's go on to some actual practical problems now that uses this. Oh, just one other thing. You'll notice that when you look at the tutorial answers, I've actually done the simultaneous equations a different way in the tutorial answers, but just use this way. It's probably going to be the easiest way going forward, unless you're comfortable with simultaneous equations. You've got some other ways of solving them. You can use whatever ways you're comfortable with. Okay, that's it.